Okay, so here we go. This is a system of inequalities. There's a couple things we're going to do here. We're going to graph each line, duh, because it says graph, but we have to determine, is my line going to be dotted or is it going to be solid? Okay, and I have to determine where to shade. And all of that is built into this problem. Remember, if it says equal, then my line will be just solid line. If it's not equal, like less than or greater than, then my line will be a dotted line. The shading part, okay, the greater than or less than part tells me I'm going to have to shade. Now, we've talked about shortcuts for figuring out where to shade. We'll do that when we do the problem. So I'm going to, for ease of discussion, I'm going to call these A, B, and C. So if we take equation A, which is, and we think of it as y equals 3/2 x plus 5, okay, we get the y-intercept is 0, 5 from that, and we get the slope is 3/2, which we almost always think of as rise over run. So we go to our graph paper, okay, and we go to 0, 5, 1, 2, 3, 4, 5, roughly right about there. And from there, we rise 3, 1, 2, 3, rise 3, run positive 2, 1, 2. Okay. Now, this line was a solid line. Okay. So I can just go like that. Remember, you label the line with the equation. This is the line y equals 3/2 x plus 5. The shading, the greater than or less than, will take place with when we shade. Well, speaking of shading, okay, this is plus 5. Sorry. Okay, the shortcut for us was when it was in slope intercept form. Remember, slope intercept form is y equals mx plus b. That's called slope intercept form. Okay, if it's less than or greater than or whatever, that tells us where to shade. Since our original problem was in y equals mx plus b, we're going to shade less than, which on this problem is going to be below. I'm not going to shade right now because it's going to mess up my problem. But I know for this line, I'm going to shade below it. Now we move to line B, which is y equals negative 2x minus 5. So again, our y-intercept is 0, negative 5. Oops. And my slope, this is where you need to be careful, is negative 2/1. Remember, slope still has to represent rise over run. So you have to be able to put in the invisible 1, even though they didn't write it there. 2/1, negative 2/1. So we start at 0, negative 5. Well, if this was positive 5, this is negative 5. Okay. And we're going to rise negative 2. Oops. Rise negative 2, run positive 1. And we're going to dot it. And we label the line as the equation y equals negative 2x minus 5. Now, again, if we look at this, it's in slope-intercept form, y equals or whatever, mx plus b plus or minus b, like that. So this says shade below this. Less than means below. So I'm going to shade below it. So think about this. I'm going to be below the black line, and I'm going to be below the red line. Okay, so already I can kind of see that I'm going to be in here, to be below the black and below the red. Okay, I'm going to be in here, but damn it, Foster, there's one more thing here. Okay, well, fortunately, I have a third color. We're going to call this C. C is x equals 2. That's the old vertical line where x is stuck at 2 and y could be anything you want because it's not listed 5, 0, I don't know, 7 or something dumb like that. But we go out here to 2. We're going to be a solid line. Okay, like this. And this is the line x equals 2. Now, it's a little bit tricky to determine where to shade on this. But think about this. X is less than 2. X is smaller than 2. Well, this is the line where x equals 2. So to be smaller than 2 is this direction. So it's to the left. Now, everybody's natural inclination is to say, oh, I'm going to shade this little triangle right here. Okay, you don't have to raise your voice that high because it hurts. But you gotta believe what you wrote up here. I want to be below the black line, below the red line, and to the left of the green line. Well, what that means is I want to be, if I had another color, I'd want to be in this area here. I don't want to be over here. I don't want to be inside the triangle, even though, you know, that's kind of where your eye naturally goes. I want to be in this region, cut off here. Okay, it doesn't go that way towards the dotted line. Okay, so fun with graphing of inequalities, all kinds of things here. Dotted lines, solid line, shading, and it was 3 of them at the same time. Any questions about that? You sure it makes perfect sense? You could do it if I gave you it on tomorrow night's quiz. You could do it on next week's exam. Okay. Then I'm going to erase up here. It is being recorded, so you can go back and double check it when I get YouTube up. A couple things I also want to put up here, talk about in the erase. We talked about it yesterday. We have a huge quiz tomorrow. Remember, part of it is going to be in class. Another part is going to be on mom, but you'll have a day or two to finish mom. Okay, you got to finish some of it tomorrow night in class for sure. And then the rest of it, mom, it'd be a couple days. I think, I forget when it's due. A couple days, whatever. You can look at mom, it'll have it. Exam is next Thursday. It's huge. It's super, super important. Okay, there is no makeup for it. Okay, because I'm giving you over 3 hours to do it if you need. You won't need 3 hours, but I'm going to give you all that time, and there's no way to make up for it. And I don't want to have to write a whole new test, and I don't want to have to write a whole new answer key. There is no makeup if you miss next Thursday. The bonus of this, I know nobody ever reads syllabuses or syllabi too carefully, but the bonus here, okay, is this exam next Thursday will replace any bad quiz score. So for those of you who were absent on a quiz or bombed a quiz or did something like this, this will go back and replace that quiz score. Okay, so you got a 0. Let's say you get 80% on exam number 1. Let's just take easy numbers. On exam number 1 next Thursday, let's say you get 80% on it, which is a B. But the chapter 4 quiz, for some reason, you were absent. Okay, well, that means you get a 0. But because of this, because of the rule that I had in my syllabus, I'm going to take this 80% and I'm going to put it over here and give you 80% on that quiz. So your grade on that quiz jumped from a 0 to an 80%, whatever the score was. You know, I don't know how many points the chapter 4 quiz actually was, but you're going to get 80% of that total. I will spend my weekend looking for the score change that helps you the most. Okay, sometimes it won't be the quiz that you got a 0 on, because it might only be worth 4 or 5 points. Maybe it'd be better to change another quiz, okay, that was worth more points. But I'll do the math on that, and I'll have that all for you. Okay, I'll figure it out. So next Thursday's exam, super duper important. Okay, there is no makeup. Take all your vitamin C, take all your vitamins, wear your masks, stay away from everybody for the next week, but be here next Thursday. Okay, it will, besides being an exam, okay, it will replace any bad quiz score that you have. Okay, even let's say you get a 90% on exam 1, but let's say you get a 79% on the chapter 4 quiz. That's not a bad score, 79%. That's a C plus, almost a B. Well, doesn't matter. I'm going to change it to a 90%. I'll change it to whatever it takes to help you the most based upon how you did on exam 1. So that's a little bit emphasis on, or a little bit of, what do I want to say, carrot of getting you to study just a touch harder because it has so much more meaning for you. Okay, and the same thing is going to happen at the end of the semester. Okay, the exam we take over 2 days at the end of the semester in December. Okay, we'll go back to replace any bad quiz or bad test score after exam 1. I'll talk more about that. So I'm giving you lots of that's why I keep saying you're not out of it yet. Okay, even if you're doing poorly right now, you're not totally out of the game yet. You can still pass this class. Okay. All right. Any questions?
Yeah, I got a question.
Yeah, shoot.
So we don't know exactly what's going to be, on the exam, but if we took all the quizzes, do you think that would help us out with majority of the exam?
You actually know exactly what's on the exam because I put that thing on Canvas last night.
Oh, okay.
Remember, it says exam number 1, I put a topics breakdown, and I told you exactly how many equations there's going to be. You want to know exactly what problems there are going to be. So the answer is, yeah, going back over your quiz. Actually, the truth is, I'd go back over your lecture notes. I'd go back over the notes that you have here. Go back over Angeline's notes on Canvas. Okay, that's what I would do personally.
Okay.
Quizzes are good, but they're kind of all over the place. And sometimes on a quiz, I test something that I don't want to put on the final exam or on this exam. Okay, your notes here, good. Angeline's notes, good. Okay, and You can spend the weekend putting together reviews and asking Lisi on Monday. You can ask me on Tuesday and Wednesday of next week. Okay, so we can get you can pump me for some information. I won't tell you. If you say, what's on the exam, I'm not going to tell you. But if you say, will you do this problem? Then I say, oh, that's a great problem. Hint, it's probably on the exam.
Okay, thank you.
All right. Anybody else?
Where again is that exam review?
The review, it's on Canvas. There's a module called exam number 1. And inside that, it has 2 things. Okay. It has a breakdown of topics. How many questions from chapter 1? What are their, not what are they, because I didn't put problems there, but I kind of described them, simplify, use PEMDAS, that kind of stuff, or solve an equation, solve an absolute value equation. I gave a description of what's there. Plus, there's a sample multiple choice exam there. So there's all kinds of things, at least on Canvas, that can help you.
Thank you.
Yep. Anybody else? Okay, so what I want to do, yesterday I covered a whole bunch, and I mean a whole bunch of chapter 7. So I want to go over that again, quicker, and extend it a little bit more and teach you new stuff. My goal, my overall goal is to be done with chapter 7 by tomorrow night. That means we're going to have to kind of work hard tomorrow night so that you have the weekend to review for chapter 7 and exam number 1, and you have Tuesday to come back and review chapter 7 and exam number 1, and Wednesday to review chapter 7 and exam number 1. So I want to finish chapter 7 tomorrow night. That gives us more days for lots of review of chapter 7, 6, and 7, review for the final, or the exam number 1. I'm sorry. I keep calling it a final. I don't know. So tomorrow night is doubly, triply important. Not only do we have a quiz, but I'm going to work real hard to finish off chapter 7 that we're in. All right. So in chapter 7, okay, the general idea is called factoring. Factor, and it means to rewrite as multiplication. Okay, that's the key. It's got to be a multiplication problem when you're done. So in chapter 7.1, the first thing we did is we looked for something that we called common. Common means all the terms share it. All terms share something. Stress on the word all the terms. So here's one example. Six x squared y minus 12y squared. Okay, and I'm not sure I want to give you this example or not. All right, well, I'll wait on it. Take a second. You got about 30 seconds. Okay, so what we said is you need to look inside this. For example, I see 6x y minus 2 times 6 y. So when I see 6x squared, I really see all of these pieces inside there. And when I see 12y squared, I really see all these pieces. So when we say common, or what do they share? Well, they both share a 6 and they both share a y. And so we talk about pull out, and I made a nice and appropriate joke last night, that you pull out from them what they had in common, and then whatever's left is this is xx, so it's x squared minus 2y. Technically, you're not pulling out, even though it kind of looks that way. Technically, you're dividing. You're saying what's 6x squared y divided by 6y. Okay, this is what we studied. 6x squared y divided by 6y is that. That's what we're really doing. We're dividing it. We're kind of doing it all in our head. And we're saying 12y squared divided by 6y. And that answer is that. So when we pull out, we're really dividing out a 6y, and this is what's left. You check your work by multiplying back in. Is 6y times that 6x squared y is 6y times 2y that. Yes. Okay. Now there's one I didn't talk about last night. Excuse me, I didn't show you. Okay. Negative 3x to the fourth minus 15x to the second. Okay. Hint, because these are negative, both of them are negative, not only can you pull out a 3, because 3 goes into that and 3 goes into that, but you can pull out a negative 3 and some more. So I'll pause, having given you that hint, let you ponder that for a minute or two. So, I'm just going to say that I can take out a negative 3x to the second. Negative 3 goes into both of these, and there's an x to the second inside of both of these. Okay. If I do that, remember, if I divide, this becomes positive x to the second, because you had x to the fourth, you took out 2 of them. And this becomes a plus 5. Keep in mind, negative 15 divided by negative 3 is a positive 5. So when you pull out a negative, when you factor out a negative, you have to remember to change the signs. The first number was negative, but now it's a positive. The second one was negative, but now it's a positive. Okay, so that is our other answer. Now, I did several of my steps in my head. Okay, I'll be happy to show you more steps, more work to that. But those are the 2 answers, 2 good examples, excellent examples of taking out what they have in common. So anybody have any questions about common factoring? Okay. Mom, when you try the chapter 7 homework, which I'm pretty sure is open. I opened it the other day, Monday, maybe Tuesday morning. I don't remember. A lot of times when they're the leading coefficient, the coefficient in the very front is negative, Mom expects you to pull a negative out of everybody. Okay, she should tell you, but we usually want pull out the negative, and then that number becomes positive, and that changes. Okay, moving on. The next thing we introduced was called, and it was, I think it was in chapter 7.2. They kind of ran together, 7.2. It's called grouping. And the hint I gave you is grouping always has 4 terms. that's your hint. Okay, we'll talk more tonight about, okay, when we have all these kinds of factorings, what do you do? What do you do? Okay, how do you know what to do? Well, I'll give you more hints later tonight or more checks, but if you have 4 terms, the chances are really good you're going to use the grouping technique. So let's try this problem. Uh, 14xy plus 7y plus 16x plus 8. Yeah. Okay. So I'm going to pause, give you guys about a minute or so to work on that. That's grouping. There's a reason it's called grouping, because you put groups symbols, parentheses in the problem. That's a hint. Okay, you do not have to do this, but last night I always rewrote the problem because when I put my parentheses in, okay, I wanted to compare. Does putting the parentheses in change the values of the original problem? And the answer is, as long as that's a plus, then the answer is no, they're not changed. As long as everybody's a plus, we're all happy, nobody's going to change. Okay, my next example will show you what doesn't. So we put these extra parentheses in, and then we ask, okay, how do I factor the first group? Well, this comes back to common factoring. What does the first group have in common? Well, they have a 7 and a y. So if I factor out a 7y, I have a 2x plus 1. Remember, when you factor out the entire quantity, 7y out, all of it, it leaves behind an invisible placeholder 1. 1 is always left over. Usually we don't need it. In this case, we did. And then we move over here to plus is separated. These have an 8 in common. So we factor out an 8, we divide out an 8, and we have a 2x plus 1. Now your check is really important, guys. Most people blow this off. But is this quantity and this quantity exactly the same? That's critically important. Are they exactly the same? If they're not, if they're even the slightest bit different from each other, then you did something wrong, or the problem's set up wrong, or something. Okay, so if these two are just the slightest bit different, you screwed up, or somebody screwed up. But since they're the same, then we continue on and we say, hey, look, they both have a 2x in common. So I can pull the 2x out. Okay, 2x plus 1, I'm sorry, I should have said. They have that quantity in common. So it's a common. And whatever they had in common, I pull out front, and the 7y plus the 8 fall together. And that's my final answer. Okay. And again, we talked about it doesn't matter whether 7y plus 8 is in front and the 2x plus 1 is in back, or you wrote it this way. That doesn't matter at all. Not at all. Okay. I want to do one more grouping problem, but to do that, I need to erase this over here. Okay, because I wrote too big, so I don't have room. Can I erase these common examples? Anybody going to yell at me? Okay, this is then this is going to be an example, another example of grouping. Okay, And it's my favorite. Oops. He, ha, me, ma. He plus ha minus me minus ma. Okay, take a second, work on that one. Okay, so here we go again. He plus ha minus me minus ma. Okay, we throw in parentheses around the first two, leave the minus sign around the last two, and we ask, does my putting in the parentheses change the value of the initial problem or the original problem? And the answer this time is yes. Because in the initial problem, ma was negative, minus. But in this problem, if you distributed the minus through, this ma is a positive. Okay, you can't change a problem. You can change what it looks like, but you can't change what it's worth. So I suggested, and there's other ways this could be taught, that you just simply cheat. You just change it to a plus. So now, if you distribute the minus, you have minus me. That's what I had originally. And a minus times a ma is a minus ma. Okay, so you're okay. What causes to happen is the minus sign right here in the middle. You're always going to have an issue with the problem if there's a minus sign here. You'll never have issues if there's a plus sign in the middle. You'll be okay. So anyway, now we factor out an h out of this, so we get e plus a, minus, we factor out an m, and we also get e plus a. Okay. Our check is, are these quantities the same? If they are, then we can factor them out like that. And we have the quantity e plus a out front and the h minus the m is left over. And again, that's my answer. So that's two forms of a grouping problem, two examples. Questions? Anybody have any clarification? Anything I can do better on? By the way, you do need the parentheses around everybody. You can't just say, I'm going to factor out the e plus a and forget the parentheses. It's a quantity you're taking out. So you have to take out the entire quantity, e plus a inside of parentheses. We doing okay? All right. Then I need to erase the board and we move on. Nobody's going to scream at me, huh? Okay. All right. Chapter 7.2 did introduce grouping, but it also introduced trinomial. Okay. And chapter 7.3 continued with trinomials. Okay. And I'll show you a clearer breakdown tonight of why they did it in two separate sections. For your purposes, you don't care. You just factor a trinomial as a trinomial. But I'll show you trinomial. Trinomial, well, let's go back up here. Grouping, remember, always had 4 terms, and trinomials will have 3 terms. So in your head, you need to have these kind of chunks. Okay, always do common. Does it have 4 terms? Then I'm going to do this grouping. So you've memorized a grouping problem. Does it have 3 terms? Then I'm going to use trinomials. So you've memorized a trinomial problem. Okay. When we said trinomials, there was a couple of things. First off, a trinomial looks like this: ax squared. It could be plus or minus bx. We don't really care. The plus or minus scares students. So sometimes you just write plus, but plus or minus c. So a is always the number in front of the squared variable. B is always the number in front of the single variable, and C is called the constant. So if that plus or minus scares you, just erase it and just put a plus there. In the end, it'll all work out to be the same. We said in factoring a trinomial, we're going to use what we call the AC method plus grouping. The AC plus grouping. So when I'm talking AC, I'm talking this A times this C. A times C. So let's try an example. Okay, example. 6x squared minus x minus 1. Okay. I want to walk through this one, and I have 100 gazillion more of these that you guys can try on your own, but I want to work through this, make sure I got everybody with me. Okay. If we do AC, that's 6 times 1, which is 6. Okay. That's wrong. I'm wrong. Check your notes. It's 6 times negative 1, which is negative 6. Sorry, that negative 6 is important. Now, your job is to think of all of the numbers that multiply together to make negative 6 and add together to make negative 1. Remember, there's an invisible 1 there. So they have to, multiply to make negative 6 and add or subtract to make negative 1. And so you quickly go through your times table as you say 1 times 6, okay, is 6, but 1 minus 6 is 5, so forget that, okay? What about 2 times 3? What about negative 2 times 3? Negative 2 times 3 multiplies to negative 6, but negative 2 plus 3 adds to a positive 1. I need a negative 1. So we say, oh, that's 2 times negative 3. 2 times negative 3 multiplies to negative 6 and adds to negative 1. That's what I want right there. So then what we do is we use that 2 and that negative 3 to break apart this. So we write 6x squared plus 2x minus 3x minus 1. So what we've just done is we've taken this negative 1x and we've rewritten it. It still is negative 1, okay? But we're kind of rearranging it. At this point, notice what we did. We took a trinomial, broke it apart, stretched it out into a grouping problem. Okay, now you fall back and you use your grouping. That's why I said to factor a trinomial, we use AC plus grouping. Okay, so I'll pick this up a little bit. Again, I write it twice, 6x squared plus 2x minus 3x minus 1. Slap in some parentheses here, parentheses here. Oh, this is that minus trick. I've got to cheat and call that a plus. Oh, you're not going to like this one at all. Okay. I could take a 2x out of this, leaving me a 3x plus 1 minus, okay, I can't take anything out of this. When you can't take anything, you can always take a 1 out. So 3x plus 1. We're almost done. Okay. There's this one problem had so many little baby tricks in it. Okay. It's worth talking about. Okay. So I looked at that. I said they have nothing in common, but they always have a 1 in common. And people always forget that because that doesn't happen that often. But then what happens? They have the 3x plus 1 in common. Yay. So we factor that out front. 3x plus 1 comes out front. And what falls together is 2x and a minus 1. And we are done. And I'm still on the screen. Good. At least I managed to do something right. Okay, there was all kinds of stuff in there. And I was talking fast. Any questions? Anything I can clarify? Okay. I really like that problem, and I'm not saying that's going to be on an exam, but if you were to make note cards, flashcards of a trinomial, this is a great one because it's got all kinds of little tricks in here. All kinds of things. It's got the 1, the invisible 1 on the X. It's got the cheat step that we have to do when there's a minus sign there. And this has nothing that we can pull out, so we pull out an invisible 1 again. Oh, there's so many different tricks here. It's a great problem. Good job, Larry. Thank you very much. Thank you. Thank you. All right, no questions. Huh? So I'll put up 2 problems. Let's see what we have and give you guys a chance to work this out. 10x squared minus x minus 3. And let's go for another one. 9x squared plus 12x plus 4. So let's pause, give you guys a little bit of time to work on that. Okay. This problem, AC is -6. I'm thinking ahead and doing a crappy job. AC is -30. I'm sorry, 10 times -3 is -30. So I'm thinking of what 2 numbers multiply to make -30 and add or subtract to make -1. Again, it's got this invisible 1 in the middle. And it would be 6 times 5. 6 times 5 is 30. 6 take away 5 is 1. Okay, but we've got to adjust for the sign, for the positiveness and negativeness. So I think we want that. -6 times 5. -6 times 5 is -30. That's the AC. -6 plus 5 is -1. So that tells me I can write 10x squared minus 6x plus 5x minus 3. Take out a 2x out of this, leaving 5x minus 3, plus there's nothing I can take out of that, so there's that invisible 1 again that I could always take out. I'm sorry, I'm doing too much in my head. Slow down, Foster. I'm screwing this up. I haven't made any mistake, but I'm doing too much in my head. And so that's not fair to you guys. Put the old parentheses in. Take a 2x out of this group, leaving 5x minus 3. There's nothing I can take out of this group but the invisible 1. So I'll take a 1 out, leaving 5x minus 3. They have 5x minus 3, so I can take it out front. And the 2x plus 1 comes together, and that would be my final answer. So given this problem here, 10x squared minus x minus 3, asking you to factor it, that's the answer. 5x minus 3, 2x plus 1. Okay. Let me move to this one. Let's see. In this one, AC is positive 36. Okay. So I want what times what makes 36 and adds to a positive 12. Well, it's 6 times 6. 6 times 6 is 36, but 6 plus 6 is 12. So I write this as 9x squared plus 6x plus 6x plus 4. So again, my 12x has been stretched apart to make 6x and 6x. Okay, we write it as 9x. I write it as 9x squared plus 6x plus 6x plus 4. Remember, I like to write it twice so I can put my parentheses and compare new problem against the original problem. Okay. This group, I can take out a 3x. Can you guys read that in the glare? Is that okay? 9x squared
Yes.
plus 6x. You can see that? Okay. Okay, if ever I write in the glare or I write too small and you can't read, please, I'm hoping you will yell at me. Okay, so I take a 3x out of here, leaving a 3x plus 2, plus I take a 2 out of here, leaving, 3x plus 2. This is interesting. I can still go down one more. So I can bring the 3x plus 2 out front. And I have a 3x plus 2 at the end. And mom will not accept that, I don't believe. I'm pretty sure. Because in this case, if you have something times itself, a better way to write that is 3x plus 2 quantity squared. So occasionally mom will throw those at you where when they factor, they have exactly the same two factors. Okay, 3x plus 2, 3x plus 2. So your answer, your best answer is 3x plus 2 quantity squared. So you need to be aware of that. Mom gets a little bit nitpicky there. Okay. At this point, let's say it was on exam and I was grading it, I would give you full credit for this. Okay. I would not force you to do this. However, I will tell you that when we get into chapter 9, we'll be using factoring again, and you will have to do this. So this is setting you up for chapter 9 stuff. We'll be doing a lot more factoring, and the factoring will turn out most of the time to be a quantity times itself. So we'll write it as quantity squared. So if you get the habit of that now, you're better for it in the future. All right, that's review 3 different trinomials, okay, for review. Any questions about those? Again, I ask, could you go home and do the homework and mom on trinomials? Okay, could you, if I threw a trinomial on tomorrow night's quiz, and there will be trinomials on next week's exam. Okay, hope you're doing homework. All right, I need to erase the board, and still talking about trinomials, but there's a trick that you can use sometimes. I defined up here a trinomial as ax squared plus bx plus c. And I very carefully made sure that I gave you trinomial examples that had all 3 numbers, an a, a b, a c. Okay. Importantly, my a was always some number, 6, 10, 9. But what happens if a equals 1? So for example, what happens if we had this? Where in this case, the a is implied to be 1. Okay, if you're asleep, wake up. If you're halfway asleep, wake up. Okay, this is a really powerful shortcut. Really powerful. If we still do the AC bit, AC is negative 21. Okay, 1 times negative 21 is negative 21. And what numbers multiply to make negative 21 and add or subtract to make negative 4?
7 and 3.
7 and 3. Okay, probably who? Okay, you had 7 and 3, but somebody's got to be a positive, somebody's got to be a negative.
Minus 7 times 3.
Good, good. Okay, now watch carefully. Okay, there's nothing up my sleeve but my arm. Okay, and the fact that the dog scratched me later. But here's my answer: x minus 7, x plus 3. No grouping, none of that trick crap stuff You're done. -7, 3, x minus 7, x plus 3. But this only works when the a value is a 1. If the a value is greater than 1, 2, 3, 4, whatever, then you got to go back and do it the way all the other ones were. Do you guys see what I did here? See how quickly it was? We still do the AC here. We still got to get 7 and 3, -7 and 3. I'm sorry. But because the a value is 1, you can just use the -7 and 3 and you're done. Pretty cool. Try those 3 problems. Okay, so the first example, AC was 8. So 4 times 2 makes 8, and 4 times 2 makes 6. Cool, but I had to get a -6, so I had to cheat in a couple of negatives there. -4 times -2 is +8, but -4 plus -2 is -6. So you got to do some thinking there. Okay. Same thing with AC is -10. Okay, so 5 times 2 is 10, but I have to get a +3, so it's got to be a +5 and a -2, and that's what I use there. Now, this one here, okay, is tricky. And, well, okay, it's tricky because your AC is -6. Okay, and people start thinking, oh, -3 times 2, or 3 times -2. Those make -6. But what do they add up to? Do they add up to, do 3 and 2, -3 and 2, whichever order, do they add up to a -5? Okay, and the answer is no, they don't. The first one adds up to a -1. The second one adds up to a +1. Okay, so beware of your first assumptions. What do I want? What else makes -6 if I go AC? What else makes -6 but makes 5 when you add them? Anybody?
Maybe 6 times 1.
Yep. -6 times 1 still makes -6, but -6 plus 1 makes that -5. So we come over here, we have x minus 6, x plus 1, and we are done. So I threw this third example in to kind of trap you. Okay, to kind of trick you, make you think. Never assume too much. We all know what happens when you assume too much. It makes, okay. I can remember teaching high school, Poway High School, taught there for, God, 20 something years. Then I went to RB High School for a couple more years, but I always have an ninth grade class of somebody, I don't know what. And I put that on the board, makes an ass out of you and me. And you would have thought the kids had never heard the word ass before. Oh my God. Oh, they fell apart. They fell apart. Okay. It was terrible. All right. So back over here, let's redefine trinomials for a second. Okay. All trinomials are going to use the, I have something I call easy trinomial. And that's where the A value is equal to 1. These are what I call the easy trinomials. Okay, you still use AC. Okay, but you don't have to do that grouping crap. But then I have what I call hard trinomials. Easy trinomials, hard trinomials. And that's where A is greater than 1. And that's where you have to use AC plus grouping. So between 7.2 and 7.3, they do just, mom does a whole bunch of trinomial stuff. Okay, but they're mixed up. Some are easy, some are what I call hard. Some have the A value equal to 1, some have the A value greater than 1. Okay, I encourage you to see somehow this easy way. All right, I want to do a couple more examples and take a break for a little bit. Okay, a few more examples of some other stuff that we haven't quite covered yet. So just hang with me. All right, we have 7.1 was common, 7.2 is grouping, and trinomials, 7.3 is more trinomials. Okay, there's another type of factoring. Okay. And it's in chapter 7.4. And they call it special factoring. Okay. And the first one I think is stupid. Stupid. For you non-English, that's spelled wrong, but whatever. Okay. Remember the problem we did earlier, 9x squared plus 12x plus 36. We did that problem, and it turned out to be 3x. Was that right? 3x plus 6 quantity squared. Is that what we got? I don't remember exactly what it was. Do you remember? Anybody remember? Oh, no, plus 4. Plus 4, you're right. So 3x plus 2 quantity squared. Remember that? Okay, vaguely go back and look at your notes. Remember I said how, actually, let me do it. It actually factored as 3x plus 2 times 3x plus 2 when you went through all your AC and grouping crap. But I said that mom wants you to do it as 3x plus 2 quantity squared. Well, there's actually a formula, okay, that you can memorize that will help you see that this factors into a quantity squared. Okay, there is a formula, there's a pattern, there's a trick, whatever you want, that shows you that if you think about it, you can see ahead of time that this will factor into a quantity squared. And again, you guys have so much to memorize. This is not a formula that you need to memorize. Okay, you do need to know about the quantity squared bit. Okay, but you don't need to know about the stupid formula for it. Just do your AC and your grouping crud, and you'll get that answer. You're okay. Okay, don't worry about that. But the second one is critical. Okay, meaning it's very important. Okay, and it's called dose. And it stands for the words difference of two squares. Difference of two squares. Dos, D-O-S. Remember, in Spanish, dos means two, so that's a hint. Difference of two squares. Couple things here. The word difference in math means minus, and squares in math means something to the second power. Now, this problem that I'm going to show you can be done two ways. One way will take you, well, 3 or 4 minutes, 2 minutes maybe, if you're fast. And another way will take you 2 seconds. That's why I call it critical. Because when I show you this, you can factor this problem in about 2 seconds if I never shut up and let you guys go to work. But here's the game. Okay. Are they squares? Can you write 9x squared as a quantity squared minus, can you write 4 as a quantity squared? So instead of saying 9x squared, what would it be as a quantity? What would you put in there? What would equal? I'm sorry, go ahead.
It would be 3x.
Yeah, 3x. And instead of 4, what would you put in there?
2.
Anybody? 2, okay. So what you've been able to do is write this problem, okay, as 2 things that are being squared, and there is a minus sign between them. Very important. If there's a plus sign, it doesn't work. You can try all day long, it just doesn't work. Okay, but that's not your answer. This is what you're thinking. Think. Okay, here is your answer. (3x minus 2, 3x plus 2. And it doesn't matter who's the plus and who's the minus. They're exactly the same. One's 3x2, 3x2, but you stick a plus in one of them and you stick a minus in the other. And I just put that in the glare. And this is important. 3x minus 2, 3x plus 2. And now it's out of the glare. Okay, check it out. 3x, 2. You say 3x2, 3x2. One's a plus, one's a minus. It doesn't matter who. One's a plus, one's a minus. It's that quick. How do you check your work? By multiplying all this back together. Remember how we would build a matrix and we'd say, okay, I have a 3x and a minus 2 and a 3x and a plus 2, and you build all this together, it'll equal that. It will. I'm not going to bore you with the details now. Okay. So what if I had 25 x squared minus 49 y squared? You want to take a shot? What do you think? Nobody? I scared you to death, huh? All right. You want to write this as somebody squared minus somebody squared. Again, this is your think step. You can, and when I say think, that means literally you can think it. You don't have to write it. But 25x squared, what would go in here as a quantity squared?
5,
And
7. Oh, X.
5x.
Sorry.
x, good. And over here, you were right.
7.
7y squared.
No, 7y quantity squared. Okay, just correcting what you said. I think you probably knew it. All right, now that's my think step. You don't have to write it down. You don't have to do anything, but you absolutely have to think that. What's my answer? If that's my think step, what's my answer? Anybody?
It'll be 5x minus 7y and then 5x plus 7y.
Bingo. Perfect. And again, it doesn't matter who comes first, the plus or the minus, that doesn't matter to me at all, but that's the answer. Okay, let's try one more of those, and then I want to move on to the third thing, and then we'll take a break. Are we kind of doing okay? I mean, a lot of my classes in the past were yelling out answers and stuff like this. You guys aren't, that's okay. But I'm concerned that you're not yelling things out because you don't understand. So I want to make sure you guys understand that. Do you understand the difference between the think step and the actual answer? Think step is how you rewrite this in your mind. The answer is how you use this to get that pattern of numbers, 5x minus 7y, 5x plus 7y. Any questions? Let's do one more of a dose problem. Dose, D-O-S, difference. The D stands for difference of two squares. Dose means two, and the S means squares. Difference of two squares. All right. What do I want? Okay. 81 x to the fourth minus 25 y to the second. We'll leave it at that. Go ahead, take a second to work that one out. So using your knowledge of exponents, this is going to be 9 x to the second. If we remember, if you distribute the power in, you get power to power, you get that. This is going to be 5y. That's your think step. So your final answer is 9x to the second minus 5y and 9x to the second plus 5y. We okay? So that's special factoring. And there's one more special factoring I want to show you. Remember, the first one I said was stupid. That's when your answer comes down to a quantity square. Okay. The second one I said is incredibly important. This thing called dose, difference of two squares. That shows up so often. The other day, yesterday, I tried to give you a little bit of trigonometry, just a little bit of trigonometry. And I talked about something called sine, only we write sin. Sine squared minus 9. You'll be doing a lot of this. You need to be able to see this as somebody squared minus somebody squared. So you have sine and 3. And this becomes sine minus 3 and sine plus 3. So that's a trigonometry problem that you're going to run into where you have to be able to factor it. Now, I can't give you the whys you're going to do this. That would be me teaching you trigonometry, and we got enough trouble in this course. But that's the kind of junk you're going to get in trigonometry. You're going to get something, and your instructor is going to say, oh, factor this. You know how to factor this. It's the difference of two squares. Okay, well, there it is. That's how you do it. And they get more complicated than that, but that's kind of it. All right, the last thing in 7.4 that I want to talk about, and then we will take a break as I promised. A little bit of number theory. Okay. In arithmetic, we have numbers called composite. Composite numbers can be broken down. For example, 6 is a composite number. You can break it down into 2 times 3. 9 is a composite number. You can break it down into 3 times 3. 12 is a composite. Oh, you can break it down into 2 times 6, or you can break it down into 3 times 4. Those are called composite numbers because you can rewrite them as something other than themselves. Okay, you can break them down into smaller things. But the other side of the coin, instead of composite, we have numbers called prime. Prime numbers cannot be broken down. They're always one and themselves. For example, 2 is a prime number because the only thing you can write it is 1 times 2. 3 is a prime number, 1 times 3. Okay, 5 is a prime number, 1 times 5. Okay, and so on. So in arithmetic, we have 2 types of numbers. Composite numbers can be broken down. Prime numbers cannot be broken down. They're always 1 times themselves, whatever they are. Well, unfortunately, in algebra, we have prime polynomials. Now, everything I've given you to this point has been a composite polynomial because you've been able to break it down into other polynomials. You've been able to do, what do they have in common? You've been able to use grouping. You've been able to use trinomials. Now you can use DOS, DOS. Okay, everything that I've given you so far have been polynomials that can be factored, that can be broken down into other things. Unfortunately, there are prime polynomials, and they cannot be factored. Now, oops, that's CBF. You need to read the directions on a mom problem. The correct answer is prime. I'll show you why. I'll show you in a minute. Just go with me. But some of the people that wrote the questions for mom allow you or want you to write CBF, cannot be factored. They will tell you in the directions, but you have to read the directions. So, for example, what if I gave you 3x squared plus 5? Do they have anything in common? No, they have nothing in common. Is it a grouping problem? No, because a grouping problem has to have 4 terms. Is it a trinomial? No, because a trinomial has to have 3 terms. Oh, well, maybe it's this DOS, DOS. Okay, well, for a couple reasons, no, because it's not a difference. That's a plus. Difference means a minus. So these are all no. So you run through this checklist in your head. And because of that, the correct answer is prime. You can't factor it at all. You just quit. Say, I can't do it. Prime, I'm done. You can't even get started factoring. Okay, let's try this problem.
Is this the third factoring?
Oh, this is the third of the special factoring, yes.
Thank you.
The first of the special factoring was the ones that came as quantity squared. The second was dose. And this is the third, which is kind of weird because it means you can't factor, is really what it's saying. Okay, so good clarification question. Thank you. So what if we had here x squared plus 7x plus 2? And you go, oh, it's a trinomial. I can use AC on it. Well, all right, fine. AC is 2. Okay. Is there anything that multiplies to make 2 and adds or subtracts to make 7? The only thing I know of that multiply to make 2 is 1 times 2 and -1 times -2. Do either of those add to make 7 in the middle? No. So we say this is prime. But you have to exhaust your list of types of factorings. Okay, I just went for trinomial right away because it was 3 things. All right, let's take about a 5-minute break. Okay, come back. We got a little bit more to cover tonight, and we're right on schedule. Let's take a 5-minute break. And we'll try and turn on closed captioning. Okay, and we'll see what happens. Yay. Okay, while we were taking a break, I was writing this on the board. Okay. Everything we've talked about in chapter 7. Okay. First, always, guys, these are numbered. The reason they're numbered first, second, third, and fourth is very important. First means first. Before you start any problem, the first thing you do is look for what they have in common. Okay, that's got to be, and I'm going to have some examples to help you with that. Second thing, dose, because second, dose, 2. Think about that. If there's 2 terms, we do the dose factoring. Second, dose means 2 terms. Third, try means 3 terms. Okay, try means 3, third, try 3, whatever. They're all tied together. This is a checklist of things you go through. Fourth means grouping because there's 4 terms. Has to be. Okay, has to be 4 terms. Okay, the other thing in trinomials, I've identified there's easy trinomials. Okay, which is when A is worth 1, and there's harder trinomials when A is bigger than 1. So this is basically a recap of all the methods that we've been talking about. What I want to talk about now is what happens when we give you a problem that has 2 or 3 of these methods in one single problem. It's a combination of all of these. Okay, so this is section 7.5. All types TYPS of factoring. So how about this? 27x squared minus 75. Okay. Well, you look for what do they have in common? Is there anything that this and this has in common? I see that 3 goes into 27 and 3 goes into 75. Think quarters, 3 quarters. 3 times 25 is 75. 3 times 9 is 27. So I can factor out a 3. If I factor out a 3, I'm left with 25. No, I'm not. I'm left with 9x squared minus 25. So I factor out a 3 out of these, and I get this. But now all of a sudden, okay, I've done what they have in common. But now I go, hey, wait a minute, look at this. Is this a dose problem? Is this a difference of 2 squares? Okay, can I write this as somebody squared minus somebody squared? I can't. 9x squared is 3x, 25 is 5. So what we just talked about, this will become 3x minus 5 and 3x plus 5. But don't forget to bring the 3 down. It's part of the answer. It's one of the factors of the answer. Okay, so there's an example. This had something in common, and then looking inside the parentheses, okay, it happened to be a dose problem. So you look at that, you do your dose thinking. Remember, we said that's a think step. You don't have to write it, but you do have to kind of mentally see it and jump to the answer. Always bring the 3 down. Never forget it. Is that okay with everybody? All right. And try this one. New example. X cubed minus 7x squared plus 12x. Take a second to do that. In fact, I'll pause this thing right now. Well, I'm going to pause it again in a second. Okay. Looking at these, the first thing they all have in common is an x, so I can pull out or factor out an x. That leaves behind an x squared minus 7x plus 12. So you've done the common factoring. Looking inside here, okay, you have to ask yourself, is it possible that that factors some more? Is it possible that it does one of these? Well, real quick, it's not a dose because it doesn't have 2 terms in there. It's not grouping because it doesn't have 4 terms. It has 3 terms, so it must be a trinomial. As a matter of fact, it's an easy trinomial because the a value is a 1. So I'm going to pause. Okay, so I've identified for you, we pulled out the x that they had in common. That was right there. It can't be a dose because dose requires 2 terms. Can't be grouping. Grouping requires 4 terms. The only thing it could possibly be is an easy trinomial because the a value is 1. So for all trinomials, we get the AC is 12. 1 times 12 is 12. But we're looking for the factors of 12 that add to -7. Well, 12 is 3 times 4, but I want them to be -7, so -3, -4. And remember, because this is easy, we can say this is x minus 3, x minus 4, and we always bring down this x that we brought out. It's part of the answer. How we doing? Questions or not? Okay. Then let's try this one. And I'll let you guys work on it. We talked about this one last night a little bit out of order. We'll see how much you guys remember. Can I erase this list? Is anybody using this? Anybody not written it down yet? Okay. Okay, so let's see. 6x cubed plus 3x squared y minus 9x y squared. 3x. Yeah, that's good. I'll pause while you guys work on that. Okay, so while the recording was turned off, I gave you guys a hint. I said we could pull out a 3 and an x. Remember, you're technically dividing it out, so that leaves, this leaves 2x squared plus xy minus 3y squared. Okay, so you pulled out the 3x that they had in common. Now, we talked about this last night, and look, we're covering so much so fast. I totally understand that you can't possibly be held accountable for remembering everything we did last night. That's why my lessons are circular. That's why I keep going back over it even as we move forward. Because I understand I'm dumping a lot of crud on you. I'm reviewing and moving forward at the same time. But one of the things we did last night is we said, "Ooh, what happens if a trinomial has two variables in it?" Well, my suggestion, you don't have to do it. There's another way it's taught. But my suggestion was ignore the second variable. Ignore the y for just a minute. We'll fix it later. We'll get the y in there later. But ignore the y for now. All right. Well, then I look at this and I go, that's a trinomial. And oh, damn. Okay, the a value is 2. So I can't use the super shortcut. I got to do the whole thing, AC plus grouping. Okay, so here I go. AC is -6. 2 times -3 is -6. But I need them to add up to a +1. So if I said 3 times -2, 3 times 2 is 6. So 3 times -2 is -6. And 3 added with -2 is 1. So just to be weird, okay, not that I'm weird, you can put these down in any order you want. The 3 doesn't have to come first and the -2 doesn't have to come second. So I'm going to write this as 2x squared minus 2x plus 3x minus 3. I'm still using the 3 and the -2. Oops, I don't want that. I'm still using the 3 and the -2 to make a 1x. I can just put them down in any order I want. Okay. You don't have to put them down in the order you wrote them in. You can flip-flop them all you want. So we can factor. I won't take the shortcuts yet. I want to. Okay. Throw factors around here, or grouping symbols rather. Take out a 2x, leaving x minus 1, plus 3, leaving x minus 1. Continue to factor this. I can take the x minus 1 out in front and the 2x plus 3 falls out. Now, hold on. We're not done by a long shot. Hang on. So I factored out a 3x. Okay, that was what was in common. I got left with a trinomial with 2 variables in it, x's and y's. Crap. Okay, so I suggested last night that you ignore the second variable, the y and the y squared. And so that's what we did. We did this problem. This was a hard, quote, hard trinomial. So we had to use AC and grouping, and we got down to here. Then the thing I told you last night was, oh, well, now we have to put the missing variable back in. And the y always goes, or the second variable, I should say, it doesn't have to be a y, in the end right there. And if you multiply that all together, okay, you'll end up with this mess. Guaranteed. We do this in math a lot. We see an ugly problem, a really messy problem. We go, okay, I'm just going to ignore parts of it that make it really messy. I'm going to do a simpler problem, and then I'm going to come back and adjust my answer to take care of the part that I ignored. And that's exactly what I did. One last thing, however, remember This 3x that we factored out originally is part of the answer. That's your answer down there. So there's a lot of things to think about. Okay. Factoring is not something you can learn in 2 nights like I've done, or even 3 nights if we work on it tomorrow night. You're going to have to work over the weekend. You're going to have to work next week. Okay. You just can't learn factoring. Now, theoretically, this is supposed to be a review, but factoring is one of those things that a lot of students just, boom, instantly forget. Okay. Is that okay with everybody? That problem right there had all kinds of little tricks and twists in it. There's all kinds of factoring all wrapped up in one. We're okay? Okay. Moving on. Okay, I want you to factor that. 2x squared plus 14x plus 4. Okay, so first type of factoring we always try to do is pull out what they have in common. It looks like 2 goes into all of them, leaving me with x squared plus 7x plus 2. By now you're going, okay, I know you, Foster. You gave us a trinomial. Okay, this is a trinomial, 3 terms. It's an easy trinomial. Okay, because a is 1. So we work through this. AC, stupid, it's getting late, is 2. So the only thing that makes 2 is 1 times 2 or -1 times -2. Okay. Do either of those add or subtract to make 7? No, they don't. So you can't go any further. Now, hello, I need you paying attention to me here. Okay, this is subtle, really, really subtle. You tried to factor it, but you couldn't go any further. So this is your answer. Do not write prime, or does not factor, or whatever the world it is, cannot be factored, CBF, whatever in the world they use. Okay, very important. And now you should be going, what the heck, Foster? Probably you're thinking worse. You just told me it was prime. But 10 minutes ago, you said I write prime or CBF or something like that. Hold on. I gave you this problem. Okay. And I told you this problem by itself is prime, or CBF, or whatever in the world it is. I can't even write it anymore. Okay. So what's the difference? Prime means you can't even get started. Prime means you can't get started at all. This problem up here, we were able to factor out a 2. So we got started, but then we got stuck. We said, okay, well, the rest of it does not factor. Okay, so this is as far as we can go in terms of factoring. This is it. That's all we do. We stop. We say, I factored out a 2. I can't go any further. I'm done. But this problem, we couldn't even start to factor it. That's why we use prime. Prime is reserved for those problems that you can't even get started with. Okay, That's a subtle difference. Okay, people don't like all these little subtleties that math keeps throwing at us, but they're the thing that, stop you in future classes or stump you, or you go, duh, what was I doing? What was I thinking? Okay, tomorrow night, we are going to use factoring to solve equations. We're going to use factoring and the Pythagorean formula, word problems. Ah, crud. And we're going to review some. And we're going to have a quiz tomorrow night too. So we got all kinds of stuff happening tomorrow night. Plus, I have a special announcement about something else that's going to happen. So please show up on campus. Be sure and bring your mask, wear your mask. And that's it. I'll see you tonight. No, I'm not taking roll tonight. I am taking roll tomorrow night. Hasta bye-bye, everybody. And I'm going to stop my